Here in this Lab 8, we are looking at making some confidence intervals for both numeric data and for qualitative data. So the first example is talking about numeric data. That is when you collect information, that information is actually stored as a number instead of as a yes or a no answer to a question. So they've gathered some information about flight delay, about if an airplane was able to leave on time, or whether it left earlier than on time, or if it left later on time. So we're going to try and get used to using some software, some R techniques. So here, one thing you can do is you can copy this line of code into your R, or you can also actually download the R code that I've downloaded to a D2L under the lab section. So here I've input my sample. So I've called the name of my sample X, and then I've used C with a bracket and then a comma separated display of the sample. Once I've done that, I can actually calculate what the average of these points is by using the command mean of what I've called X here. So here I can actually calculate the average and then store that information into a spot that I call mean. So I'm going to do that. And then I can actually show myself what the average was by recalling the value mean. So that is the samples mean. Let me just put that where it goes here in the question. And then here I can also calculate the sample's standard deviation. So I can calculate that and put it here into R. And then I am trying to look for the confidence interval. That is, in this case, part B, the central limit confidence interval. So because I don't have information about the population standard deviation, which would be a sigma, I only know what the sample standard deviation, which is being represented by the letter S here. I have to use the student t distribution instead of the normal distribution to make this. What you can do, of course, is view some of the videos that we've gone through to how to make this, but I have also in my R code used a command that will actually count the number of points in my sample. Instead of actually counting it by hand, I can use this command called length to count up the number of points. And then here I've said if I want my confidence interval to be 95%, and then I can throw these formulas together to actually get what the confidence interval bounds, both the lower and the upper estimates for what the average could actually be. That is, the population average could possibly be between this value here and this value here, and I'm 95% sure that it is. What's particularly of interest in this case is that my confidence interval actually includes the number 0, so it goes from a negative to a positive, which means 0 is actually in the interval. So is it possible that on average the flight could leave on time, which means 0 difference between when it was supposed to leave and when it actually left? Because that value of 0 actually does fall in my possible interval from negative to positive, then it is possible to say yes, it is perhaps conceivable to say that on average um, uh, the airplanes do leave on time. So that is a confidence interval using the central limit theorem and using this formula here. However, new methods have been shown to be able to make confidence intervals in a different way, which is the Bootstrap confidence interval. Again, you can go back to some of your lecture notes to learn about that. Um, One change that I'm going to talk about here is originally in part B, we are talking about a 95% confidence interval. And now in part C, we're going to change to be a 99% confidence interval. So we are increasing our confidence, which is probably a good thing. You probably would like to be more sure of something, but the downside of increasing your confidence is that your interval will get wider, because if I wanted to be 100% sure that I was going to guess your correct final exam score, then I would have to include more possibilities. So if I wanted to be 100% certain of what somebody is going to get on their final exam, I would have to say in between 0 and 100%. However, if I'm allowing myself some error, and I can say, well, I'm pretty sure then I can make a statement more like, I'm pretty sure that you'll get in between a 60 and a 90 on your final exam. So when you change the level of confidence from smaller to bigger, realize that you will be making your confidence interval wider. So the particular predictions that you're making will not be as accurate. Okay, to do the Bootstrap confidence interval is a little bit complicated, and again, I'd refer you to our lecture notes where we went over that particularly. However, if you really want to make sure that you have the computer choosing the same random selection as the computer that is behind web work, then we need to make sure that we are having the computer choose randomly the same way twice. So one thing that you need to do for sure is to make sure that you have the package Mosaic installed. So I'm going to go to packages, I'm going to go to install, I'm going to start typing Mosaic, and you can see that it starts to pop up. I'm going to click on that. I'm going to make sure that install dependencies is checked, and then I'll say, please install that. So it's going to take some time, and it's going to install the package called Mosaic. And then once that's set, you can actually just copy and paste this line of code, making sure that we get the same random samples as each other. When you are looking at your assignment questions, this will be the same for assignment questions. So let me just quickly pop open what your assignment questions look like. Assignment 7 here. When you go to a particular assignment, let me just find a problem that actually has this kind of question in it. When you find a question where you do need to bootstrap, notice that it actually gives you the code to copy and paste into your session of R so that you can get the same randomized samples as your web work is taking in the background, so you can make sure that you get the same answer that is expected. So that is one thing when you're looking at your assignments that you can make sure of. Okay, so excuse me. After after following the code provided to you, you can get a bootstrapped confidence interval. Here I'm increasing the confidence from 0.95 in the first part of the question to now 0.99 in this last part. And here I'm going to get a bootstrapped interval where the lower limit is given, and here the upper limit is given. And so these two confidence intervals are really trying to say the same thing. There's some slight differences. One difference is that we use the central limit theorem to calculate this confidence interval. And also the other difference is that we used a different confidence level. So here we used a 95% confidence interval on the central limit theorem. And here I used a 99% confidence interval using a bootstrap technique.